Hey guys, welcome back to Data Bracket. I'm sorry it's been quite a while. I have not posted a video of lately. In a few days, I'm going to take up a new assignment as a data engineer on Azure, and I'm trying to learn Azure now. Basically, I'm trying to figure out things and understand what are the different services that Azure offer and how we can get things done in Azure. And as a starting part, all of you who are from Azure background know that we need compute to do anything in Azure. So I was trying to see how we can spin up any compute resource in Azure to deploy our workloads. So in AWS, we have EC2 instances, which we can spin them up basically and deploy our workloads onto EC2 instances, either through AWS console, or we have Boto3 library, which is a Python SDK, and we can use AWS CLI as well, or we can use AWS Terraform provider, which AWS provides. It's exactly the same process, but Azure has its own SDK, Azure has its own CLI, and Azure has its own Terraform provider. I was trying to see which one is optimal among those three, and I tried to spin up an instance, create a resource group using like all three approaches. So I end up settling for Azure SDK. I want to get your opinion on which is better among these three. So I know that we can use to deploy workloads and maintain infrastructure using Azure Terraform provider as infrastructure as code, or we can use Azure SDK to write Python scripts which can streamline and automate an entire pipeline or an entire process of deploying, handling, maintaining, monitoring, and alerting a task. And for simple operations we can use Azure CLI, right? But where is fun in that? You can wrap all your Azure CLI commands into a shell script and you can basically automate that as well. So that is what I tried, and this demo is more about showing you how you can define an Azure resource group and spin up an Ubuntu virtual machine in the resource group using Azure CLI and Azure SDK and Azure Terraform provider. And I'm going to walk you through what I did in those code samples, and I'll show you what you have to do in order to spin up a virtual machine in Azure, and how you can create a resource group in Azure and how you can automate them in your pipelines. I wanted to record this to show newbies and people who want to automate Azure in different ways. This should be a very good learning exercise for them on how they can create a virtual machine and a resource pool using Azure SDK or Terraform provider and CLI. So remember that this channel is all about action and not theory, so please try to check out my Git pages where I have documented everything about this process, and the code is also available in the Git repo. And try to subscribe to the channel so that you don't miss out on any action. So let's dive right in. So here we are in our module. So let's first see how we can accomplish things using Azure CLI. So Azure CLI, you can install it directly through pip as well, like pip install Azure CLI. You can just go to the documentation and you'll find a pretty neat demonstration on how you can install Azure CLI. But let's see what commands does Azure CLI has to offer. Let me go back to the main directory. Okay, this is Azure demo directory. Let's see Azure help. They should give us all the commands on Azure CLI. Okay, this is way too much. Let's try to put everything into a text file. Let's say azcli.txt. This should give us a text file with all the commands. Okay, and we have the file. Yeah, these are all the commands. This is the group name, and this is what you start your Azure CLI with, and these are the subgroups. You can interact with all Azure resources using these subgroup names. So in this demonstration we will use mostly group and VM. So we have group. Where is group? So this will manage resource group and template deployments. We will work on resource groups, and we will use VM subgroup, which will help us manage Linux or Windows virtual machines. We have pretty much every other subgroup here which you can use, which have pretty good description on what it does, and you can go to Azure documentation to see how to use that, or you can keep following my channel, and I keep posting videos on all these subgroups and all of the services that Azure has to offer as I keep learning them. So let's go to the CLI first. So this is a simple bash script that I created. You can run this commands directly one after another, and you can pretty much accomplish the same, which is a static approach, and it is only usable once, and every single time you run it you have to change the configuration if you have to redeploy a different resource. But using this approach, you can simply export your variable names and you can keep running this to as many resources as you want, and you can spin them up in Azure console. So basically what I'm doing here is I have a simple variable which is having an operation which is nothing but Azure group, which have a subgroup which is the group name. This is creating our resource group. So this create will accept two parameters, name and location. Name is the resource group name. This can be anything of your choice, and location is the cloud location, US East, US West, or depending on what locations Azure offers. We will use US East for now. And resource group is our Azure CLI resource group. This name can be anything, as I said, you can rename it. So this will pretty much create an Azure group. That's it. Through CLI you just have to call this to create an Azure group. And once you create the Azure group, you can create a virtual machine inside that group. To do that, you can simply call Azure VM, which is a subgroup name, create. The resource group is the flag that it expects you to provide, which will expect the resource group name which we passed in the resource group. We will pass the virtual machine name, what we want this virtual machine to be named as, and the image, what image you want this virtual machine to be of, either it is Ubuntu or a Windows virtual machine. We are using Debian. As Linux have multiple flavors, you can use any flavor of Linux. And you have to pass the admin username, which is required parameter, and you can either use password by passing the password field, or you can generate SSH keys using which you can SSH into the virtual machine. And if you want the public IP to be enabled or not, that is a flag here, which is the standard option that I'm passing here. So this is everything that you have to pass in order to create a virtual machine. And I have created this in order for us to delete the group after a specified sleep time, or after any operation that you want to perform on that virtual machine. Let's say you want to execute a block of code on that virtual machine. Once that is done, you can delete this resource by calling this simple delete option. Here you follow the same process like how we followed for the group creation. We can delete the group by passing Azure group delete, the resource group name. No wait means it will exit from the command immediately, and it will terminate the or it will delete the resource group in the background. It will not wait in the terminal for that resource group to be deleted, and it has to keep on checking if it is deleted or not. That is what this no wait flag is. And verbose is nothing but it will give you more details on what is happening, and I'm simply echoing everything. Let's try running this. So Azure CLI accepts you, like it expects you to log into Azure using AZ login. This will help open up a browser, and it will ask you to do either single sign-on or manual login. Once you log in, the credentials are locally saved, like how it is saved in AWS in your local directory in .aws folder. Here everything will be saved in .azure folder, and this will open up a browser and it will ask you to log in. Once you log in, you have to just run this shell script in order for us to execute this and create a resource group. So let me go into our Azure console first. I'm sorry, AWS keeps coming into my mouth because I was very much involved in AWS stuff. So here we only have 3 resource groups, and if we are to see virtual machines, we don't have any virtual machines, right? So let's log in first. Let me log into Azure. So a browser opened up for me. This is the browser, and yeah, it has logged in successfully. So let me close this. So I have logged into Azure now. Let me run this shell script. I just have to call sh. Okay, let me cd into the main directory where this script is residing. It's in Azure demos resource groups. Okay, here we have the directory. This is the git repo, so then I'm in the master branch. So sh cli.sh. If I run this, it will do the magic behind the scenes. So it has echoed us like what it is doing, like it is saying creating Azure group. It has created the resource group, but this is the response we got from the resource group, and it is waiting for the virtual machine to be hosted. So we can see the operation that is happening inside the virtual machine. Let's go to our Azure console. Let's refresh this. We don't see any virtual machines, but let's go to resource groups. We have a resource group, Azure CLI resource group now. Inside this resource group, we can see one deployments. But before that, we will have to wait for all the resources to come up. We need VNet, we need public IP, we need 4 to 5 resources in order for us to spin up an virtual machine. Let's wait for these resources to come up, and the virtual machine will be up any moment now. So yeah, we have VNet, we have public IP, we have security group, and we have virtual machine. Let's see what this deployment is. So this is the virtual machine. As we can see, this has already been successfully deployed. Let's see if that is, yeah, we can see that the virtual machine is showing up in our virtual machines console. So that's all about the Azure CLI. This is all that it takes for you to spin up an Azure virtual machine and create a resource group. Naming is up to you, and you can play around with the Azure CLI commands, and you can control what you want to do with this. Let me delete this resource groups in order for me to save little pricing, and I'll come back once I delete this. Alright, so our resource group is deleted now. So we can see here the shell script has executed, and it was able to successfully create a resource group with this, and it created a virtual machine successfully as well, and it was waiting for 3 minutes in order to run the delete command. But I manually deleted the resource group before this in order to save compute costs on the Azure console. So yeah, this is how you can accomplish resource group and virtual machine creations through Azure CLI. You can play around with this if you want. So let's move on to Azure SDK now. So as we saw in the Azure CLI, we just had to call group creation, VM creation, right? But in SDK, we'll have more control, and we'll have to do a little bit of extra work in order to create a resource group and a virtual machine. So resource group is straightforward. You just have to call a simple operation on the resource client, and you can create a resource group. But in order to create a virtual machine, you need to create network resources like virtual network, public IP address, and network interface. And you need virtual network, you need subnet, you need public IP address, and you need network interface in order to simply create a virtual machine. In CLI, this is done behind the scenes, and everything happens under the hood. Let's see how we can do this in the Azure SDK using Python. So first thing you need are these 4 libraries. This comes packed inside the Azure CLI, which when you install Azure CLI using pip, this will get installed automatically. If you want to install them individually, you can just check out Azure documentation, and you will have commands to run this individual through pip. So I'm using config parser in order to read the configurations. So I created this script as a dynamic script. I have all the environment variables here. So this contains the resource group name, the location, the virtual network name, username, password, and whatnot, all the things that we need in order to create a virtual machine, all the variables are here. And I have my subscription ID. Azure SDK expects you to pass a subscription ID in order to connect to Azure console. So we'll see how we can pass that subscription ID. So here I have imported 4 classes from Azure. So first one is Azure credential, Azure CLI credential. This will connect to the Azure CLI credential, and so this is just a simple class that we instantiate in order to connect to Azure using credential and subscription ID. So first is resource client, using which we can define and manage resources. Second is network management client. The name itself implies that we can manage and handle network resources. And compute management client helps us to do everything which is related to compute resources. So this is my standard approach to read configurations so that I can make them dynamic and save them in a separate file, which I can change whenever I want in order to redeploy them somewhere else. So if you have been following me, or if you watched my earlier videos, this is the standard approach I follow using config parser. I read all these environment variables through this environment variables.ini file, and these parameters comes into play during runtime. So first thing is I have created this instantiate Azure method, which takes the subscription ID that we are passing through the environment variables. This will call the Azure CLI credential class, and with this class instantiation we'll have a credential client that we can pass to the resource manager, network manager, and compute manager along with subscription ID. This will help us to connect to Azure through Python. This is how you can connect to Azure. In CLI you have to log in manually, but in SDK this is how you can connect to Azure using the subscription ID, or you can use service principal as well, that we see as we go along, but not in this demo. I have to create a different video, but once I learn other things, I will add how to interact with Azure through service client. I'll add that demonstration as well. For now, let's stick with the subscription ID. So this will return all 3 clients: resource, network, and compute client. And we have create resource group class that takes the resource client from this instantiate Azure, and this resource client needs a resource group name and location. Similarly, how we saw in Azure CLI, we have to pass the group name and location where it has to be hosted. So this will use this resource client that we are passing during runtime, and it will call a resource group method on top of that client, and it will call the creator update method. This will accept the resource group name and the location, and tags are optional. You can pass tags, and you can pass other information as well to the resource group based on the documentation if you want. I'm keeping it simple and only passing location, tags, and group name for now. So this will create resource group for us. This is all we need to create resource group. In order to create a virtual machine, we have to go up and down. Let's see what we have to do. First, we need to create a virtual network. So virtual network will expect a network client, which is a default class to interact with network resources, and it will expect the resource group name, a virtual network name, what should be our virtual network name be, and location. This follows the same design. It will use the network client and calls the begin creator update method on the virtual networks, which accepts the resource group name, vnet, location, and address space. This is nothing but the address prefix, similar to AWS subnets. This will expect the subnet prefixes in a range, and you can pass this based on your availability of your cloud resources. And this virtual network have a method called result, which will give us more information about what is happening inside this operation once it is executed. Like we can extract the ID, we can extract the name from the JSON that we receive from this run, right? As we saw in the shell, once we create that, we get a response in JSON format. Using this result method, once we call it on top of the virtual network client, we can extract that JSON information one by one using the JSON objects. so that we see as we go along. I'll show it in the end where I'm extracting the information in order to pass to the next methods. So once we create a virtual network, we need create subnet. It follows the same design. Actually pretty much everything follows the same design here. We'll create a subnet which takes resource group, subnet name, virtual network name, and the same model, more like the same design is there, and I have structured everything similarly for subnet, for IP address, and for network interface. And here in network interface we have to see that I'm passing subnet ID and IP address result ID additionally. So this I will show what are these in the end, but rest all is same for all 5 methods until here. And for create a virtual machine, we are using compute client and we are passing resource group name. What should be this virtual machine be called as? The location, username, password, and network interface name ID. This is also I'm going to show in the end. And this is following the pretty much same design, and it's gonna call begin create or update method, which takes resource group name, virtual network name, location. The structure is standard. You can see this and get it from the Azure documentation. And I have added simple print process one so that we can know when this virtual machine is provisioning. So here I have wrapped all the methods into one instead of calling one by one in the run. So this will create all the network prerequisites. It will take the network client and all the elements that we have passed in every single method here, right? So many of these are common for all, so I have used a single element of all these duplicates, and I'm passing them to this call create network prerequisites methods. Here it will create virtual network, subnet, IP address, and network interface. So after the creation of all these elements, as I said, we'll get a JSON response, right? So the subnet will return us the result option, right? So here on subnet, once we call that network client operation, we get our response. Our response is stored in the subnet variable. On top of this subnet, we are calling this result call. So this will help us to interact with the JSON. So once I call ID on top of it, we'll get the ID of the subnet, or we can call the name, or we can call other information that is structured inside that JSON. So I'm using this ID to get the ID, which is what I'm passing in this method that I told I'll explain in the end, right? So these are the required fields for us to create a network interface. So I'm extracting them from the above methods and I'm passing them in the next operation. That this is same to the network interface ID as well. All the IDs are coming in from here and I'm passing them one by one, and this will create the network prerequisites with a single call. We don't have to keep calling every single method and in order for us to create. This will do the job for us so that we can run everything dynamically. And this will delete the resource group in the end after the virtual machine comes up, and if we have to perform any operation on top of that virtual machine, we can call this delete resource group and it will delete the resource group in order to save the compute costs. So in the main method, I'm simply using a try except condition to catch the errors or run this. So I'm calling the instantiate Azure method, which returns us all 3 clients, and using these clients I'm passing them into the next operations. And these are the variables, like all of these variables are taking the values from the variables that we have created from the config parser above. So all the methods are being called. We are calling create resource groups. This will create the resource group, and this will create all the network prerequisites using this method. And with network prerequisites, we will create the VM and we will add 3 minutes wait time and we will delete resource groups, just like how we did for CLI. But this is a little extra code and we have to do many things in order to create a virtual machine in the resource group. CLI is pretty straightforward. You can simply call 2 to 3 lines of code and you can accomplish the same approach, but you do not have more control on what is happening. And if you want to declare variable names, or if you want to connect one service to another, and or if you want to extract information in a format that you want, and you can parse that information as you go along. In shell it becomes complicated, but in Python it's very simple and you can accomplish more, but with little bit of extra lines of code. So let's run this. This should do the same job for us. I'm gonna simply call python azsdk.py. So before that, let me add the subscription ID in the environment variables. Alright, so I have added the subscription ID. Let's run this. So it is initializing the Azure clients. As we can see what is happening here, it gives us pretty much decent information, like it says initializing Azure clients and provision the resource group in each region, and it gives other information as it proceeds. So let's go to our console and see if that has come up or not. So in the resource groups, we have Python SDK example resource group. This came up just now, and it don't have any deployments because it's still provisioning. We have to wait for it to complete. What just happened? It says our password is not long. Let me increase that. Alright, I made the password a little complex, and I have deleted the resource group from the console. So let's rerun this. So as we can see, we don't have the resource group now. Let's run this. So this have initialized the client, and they should create the resource group in a few seconds. So it has provisioned the resource group by this name. So this name is again optional, and you can change it if you want, and you will have more control using SDK than CLI, and you can name your resource, and you can connect them, and you can play with them. So it would take a few seconds for the resource group to reflect in the console. Let's wait for that to happen. So it says network resource is also provisioned, and yeah, VM provisioning is in process. So this print is happening through this. So the create VM method has successfully completed this, and it is right now in progress. So now our resource group should be reflecting. Oh, still not reflecting. Yeah, I got it now after refreshing the entire console. So if we can see, we have more control on the naming now here, and we have more control on what configurations goes into that particular resource. So this is the address space that we passed, and we have configured this specifically. You can pass other specifications as well, but we'll keep it simple for now. So this is the resource group, and let's see where our virtual machine deployment is. So Python example virtual machine, it is available. So let's go to our virtual machines to see if we have, yeah, we have our virtual machine here. This is also available. Yeah, this is how you can create a virtual machine and resource group using Azure SDK using Python, guys. And I'm gonna delete this as well manually instead of waiting for the Python script to, okay, guess what, let's wait for the script to do its job and see how it does it. So it anyways delete the resource group in 3 minutes, so let's leave this running till then, and let's switch to the Terraform option. So in the Terraform directory, okay, let me delete this so that I can show you guys live what is happening and how you can execute this as well. So I'm basically deleting the Terraform initialized content and deleting the state of the Terraform. Yeah, so these are the 4 files that we need in order to accomplish the same task that we did using CLI and SDK. So first thing is, okay, it says resource group deleted successfully. So let's go to our resource group, and the resource group should be in deleting status. Yeah, it is in deleting status. Let it get deleted. And while it is deleting, let's go back to our Terraform. Yeah, so let me close this. Here we are. Let's start from the main. Okay, let's start from the providers. So providers will take the Terraform provider version that you want to pass and the source from the HashiCorp. Azure RM is the provider name, and here as well you have to pass the subscription ID, and features is an optional flag, but you have to pass the features as an empty dictionary. This is an optional dictionary. You can leave it empty if you don't want to declare any features, but you have to define the features flag here with an empty dictionary, and the subscription ID with the subscription ID. And version is 3.3.0. the latest version is 3.62.0. I believe I'm using the lowest version because the recent version is not compatible with Windows 11, and it was not allowing me to do the Terraform plan. It was stuck during the Terraform plan waiting for the host to respond in a timely manner, which was not happening. So I downloaded it to 3.0, and this is working pretty decent, so I'm sticking with this for now, only for this demonstration purpose. You can use higher versions if you are on Mac or Linux. It's up to you. So this is our providers. So let's go to the variable main file. So in the main file, this again is similar to our Python SDK example. Here we have to declare everything by ourselves, not like CLI. We will use the resource flag to create the Azure resources. Everything is a resource in the main. So I'm passing it as a resource, so you can pass anything you want. So here we have to call the resource group object, and inside that you have to call the RG to create a resource group. This will create a resource group with the name tf test rg. Alright, so it will take the location as we saw earlier, the name, location, and tags. Tags are optional, but you can pass them if you want to handle your AWS or Azure resources for compliance and other purposes. And we don't need this. I'm sorry, why did I keep that? I don't know. So we have the resource group, we have the virtual network as we saw earlier. We give as a default name. You have to pass something here, and the name is also required. You have to pass the name, which reflects in the console, and this will reflect in the Terraform plan. So this is the resource name of Terraform. This is the resource name of Azure. So this will reflect in the Azure console. This will be in the Terraform plan once we run Terraform plan. And we have group, resource group, we have virtual network, we have subnet, we have public IP, we have network interface, and we are creating a random password. Yeah, the virtual machine is also being created. We are giving the virtual machine a name, how many virtual machines we want. Its location is coming from the variables, and so this is like the Azure resource group is the resource group that we created with the resource group name and what location you are passing here. This is being picked, Azure resource group dot location. If we want name, Azure resource group dot name. That is how all these elements are defined. So the resource group name and network interface ID, we are taking the network interface that we created here, NIC, with the name. It has the count of the index, and it is again taking all the elements from the variables file. Here we have declared all the variables. So the resource group location, which is East US, which is of type string. Description is optional, and group name prefix is also string, and RG. Username is Azure admin. Password is 1234. Let's make this complex for this demonstration only. Okay, this is a complex password, I believe, and this is how you define, and what all the configuration you pass inside this resources is again similar to what we passed in the Azure SDK. Here we are passing the address space, and here we are passing the address prefix, and we are passing the my public IP allocation method, and whether you want the public IP to be dynamic or static, and the subnet IDs, and you're passing the type of the virtual machine, whether it is Ubuntu or it is Kali Linux or any other server. I'm using Ubuntu for this, and we're passing the username, password, and authentication. If we have to disable, we don't want to disable authentication, so we're making it false. So with these two, I think we can't use dollar here. Okay, let's keep it till 8. I don't think Terraform is liking the password that I gave. So this is main variables and providers, and we have outputs. This will output everything in the terminal once we run Terraform init and Terraform plan. This again outputs whatever the variables we want, like we want the resource group name to be outputted once it is created, virtual network name to be outputted once it is created, and stuff. Right, so let's run this, and before that let's see if our resource group is deleted or not. Close this, refresh. Yeah, our resource group is gone. And let's see if a virtual machine is also gone. Good. So that is out of the picture now. So let's do Terraform init. So this will download the Terraform provider from the HashiCorp portal, and it will keep that Terraform provider in a Terraform directory inside this. So once I run this, okay, I'm not inside the Terraform directory. Let's cdtf. So that is where our Terraform code is residing. So let's go there and let's run Terraform init. So this will download the Terraform Azure RM provider, and it will create an Terraform directory here. So yeah, .terraform directory is created, right? So yeah, our initialization is successful, and we can do now Terraform plan, and this will give us the plan, but the plan might change when you run apply, so it's a good practice to output the plan to a file. I'm gonna call it virtual machine resource group.tf plan. tf plan is the extension for Terraform plan, and you can output it into a file like how we did for Azure commands in order to see all the commands that are available, right? So you can do the same with this. Once I run this should execute the plan, and it will give us the clear blueprint of what will happen. Oh, I have to add subscription ID to this as well. Let me add that. Okay, I have added subscription ID now. Let me run the plan again. This will take at least few seconds to finish, and it has already created 2 log files that we can't alter, modify, or even see the plan. We'll get the blueprint inside the terminal itself, and we can see how many resources are about to be created, how many of them are validated, and how many of them are not going to be created. We can see the plan says it will add 6 resources. It will not change any resources because we don't have any resources already, and it will not destroy any resources. So it says it will create a virtual machine with all this information, which everything is a create, and it will create a network interface, and it will create a public IP, it will create a resource group, subnet, and a virtual network. So these are the 6 resources that get created using this plan. I'm not gonna apply this plan because I've already run it twice using CLI and SDK. You get the picture like what happens once I run the apply. It will create the resource group, and it will create a virtual machine, and once I run the Terraform destroy, it will destroy those resources from the console. I hope this was useful, guys. So this demonstration actually tries to demonstrate everything that I did using Azure CLI, Azure SDK, and Azure Terraform provider. This might be a very good learning opportunity for you as well if you want to implement these approaches in your project or in your organization. The code is again available in the Git repo, and you can subscribe to my channel, and you can fork the repo, and you can keep checking the Git pages. I keep updating stuff there. I'm going to start contributing more towards Azure as we go along, and you guys will see more videos from me on Azure DevOps, DataOps, MLOps, and data science. Thank you so much for sticking all along, and have a good day. Bye.